Suppose I want to convert the following to logs. Now I have 10 to the fifth, which I know 10 to the fifth is 100,000. So if I convert this to logs, remember it's the common log because of the base 10. So it'd be log, and then remember the exponent goes on the other side of the equation, so I end up getting log of 100,000 is equal to 5. And then my second example is 10 to the negative 4, so that's 0.0001. And so if I convert that, that would give me the log, and then remember it's the log is a common log, so it's base 10. And then I know that the exponent is negative 4, so that goes on the other side of the equation. So I get log of 0.0001 is equal to negative 4. Now, a couple of things that I can notice here. Notice when we talked about this before, the log of 1 would actually be the same as saying the log of 10 to the 0, and we actually know the log of 1 is 0. The log of 10 would be the same as saying the log of 10 to the first, and notice when we did that, the answer was 1. The log of 100 would be the same as doing the log of 10 squared, and notice the answer gave us 2. This actually inspires one of the rules that we're going to be using. The rule we're going to be looking at is the log of 10 to the p equals p. So if I see log evaluated at 10 to a power, the answer will just end up being the power. That really has to do with the fact that log base 10 and the power 10, the exponential 10 raised to, are inverse functions. And as we said before, inverse functions basically cancel each other out. We have to be a little careful with that language, but that's the way we kind of think of it. Notice also that if I take 10 and I raise it to the log of a number, 10 raised to the log of 1, for example, will give me the number, give me 1. So 10 raised to the log of 1 is 1. 10 raised to the log of 2.75, for example, will give me 2.75. And if you're not convinced, try that in your calculator. Notice that no matter what number you pick, 10 raised to the log of it will give you that number, with one small caveat. The number has to be greater than 0. So notice in general, 10 raised to the log of p is going to equal p for all p greater than 0. Now note again, I mentioned this, that p has to be greater than 0, and that's because the log of x is only defined for x greater than 0. And we'll talk about that a little bit more as we move through the chapter.